what do you think are the basics that will help anybody?
Instead of long int, you would use uint 6040 and things of these nature.
The concept of interrupt handling remains same whether it is RISC or ARM or x86 as well.
So my training and my job was completely different.
There is no single guide actually.
So let's go around the table and take notes on what helped you. And then, towards the end of this talk, what we can do is crystallize, the must do's and good to do's and the can do's. Okay. Who wants to go first? How did you get started with embedded system and what all helped you?
So I think I would just like to start with the point like there's no single guide actually. The industry, the embedded industry within itself is so vast that
Mm-hmm.
what may work for one may not work for others, what may work for others may not work for one. Like I can give you an example. If you are working on a TCP IP kind of, let's say you are a middleware engineer who mostly works on L2 and L3 layers of the switch and maybe on the kernel stack, maybe you don't want to know the CPU architecture.
Fair.
You don't care whether it is ARM or RISC. My C code is gonna run on it. I'm just gonna left it up to compiler to figure it out.
Mm-hmm.
All I care about is the IP, the Mac controller I have, and the PHY I'm
True.
talking to.
True. But let me put the question this way. Say you were a fresher,
Okay.
right? Or let's say you were like 3 to maybe 4, 5 years, experience, and you wanted to change jobs, right? You wanted to make a shift. What do you think are the basics that will help anybody? Because
So
I suppose
there,
what I'm going
yes.
after is what are those core things that you think are helping you all throughout, irrespective of what niche you pick in embedded systems.
Okay. So the answer of it lies on the fact is what is the difference between a software engineer writing C and an embedded engineer writing C, right? So some
Okay.
of the things definitely you need to know a programming language, and given the field of embedded today, it is by default C.
Okay.
And
Okay.
what separates embedded with the software industry is that you need to know a bit of hardware as well, right? Because you are programming a hardware. And how it
Mm-hmm.
differentiates is irrespective of what kind of thing you are programming, you should know what an interrupt is and what an exception is and how you can
Okay.
handle them.
So when you say hardware, you're specifically saying CPU.
No, it can be peripheral. Let's say I can take the example of TCP IP again. You are working with a Mac. How does Mac notify you that there is a packet that has arrived? It's an interrupt coming from the Mac controller, and you need to handle
Fair.
that interrupt. So
Mm-hmm.
interrupts in general. So nowadays CPUs do a good job at abstracting, and the interrupt interface, that means writing the ISR, kind of looks similar to all of them. And specifically, if you are working on Linux kind of operating system, working on their middlewares, there is already a great framework around it.
Okay.
But yes, you should understand what an interrupt is and what a context is.
Okay. So let me say some generics. Right. So I would say C language is a must. Then maybe, interrupt context,
Yeah.
and being able to write ISRs. That's
And
second.
exception handling.
Okay. And exception handling. Okay. Right. So maybe let's go back to the point when you were a fresher. What all
Okay.
did you know?
So I started with typical Indian education. We started with 8051, learned about
Okay.
8051 and assembly.
Okay.
Uh, for I guess first part of the course, and the second part was using C code to write some of the LCD controlling etc. demos on the kits
Mm-hmm.
that used to come for 8051, right?
Mm-hmm.
But
Okay.
again, I would go back like I when I came fresh out of college, I knew 8051 and a bit of ARM7 TDMI
Mm-hmm.
because that was what was taught in college. But when I
Okay.
started fresh at Atmel, my job was to work on AVR.
Okay.
Uh, so even though these are two different, very different architectures, if you abstract them properly, the concepts still remain the same, irrespective what CPU it is.
Right.
The concept
Okay.
of interrupt handling remains same, whether it is RISC or ARM or
Hmm.
x86 as well. The mechanism is a bit different, which you always learn on the job. You know,
Fair.
the
So
industry
in
is always
terms,
moving.
hmm, hmm. So in
So
terms of generics, it
yes,
was the interrupt mechanism, like the
E-
general mechanism.
yeah. So
Hmm.
overall, as I say, is you should know how to talk to the hardware. That means you should know memory hierarchy. You should know how the peripherals are arranged, how the buses work. Means
Mm-hmm.
not know into like you should know the AXI protocol. You should just know that okay, I need to do star U in 32 T star
Hmm.
to access the address space,
Okay.
or U in 16T or U in 8T based on the architecture you're using.
Right. Right. Uh, okay. So maybe let me take it down as the ideas around these and then how to reach these using C.
Yes.
Right.
And
Okay.
one
Fair.
of the interesting questions that was asked to me during my interviews at Atmel was linker scripts.
Okay.
So that is again, I said right. So it all depends on what is the difference between software. So Atmel does a lot of low-level work for the high-level OEMs. So there are a
Mm-hmm.
lot of work involves linker scripts, etc. So they were more interested in candidates who can understand that, work with that.
Fair.
The same if I would have done the same job interview at maybe Cisco's switching team, they might be more interested in me knowing TCP, IP, etc. And they might be
Fair.
fine not knowing linker scripts. So
Fair.
yes, but what helped me get into Atmel was they asked me linker scripts and I was able to explain linker scripts.
Okay, fair. And you explained what about the linker script in the sense the syntax or the idea of it, that the linker uses it, what exactly? Or maybe could you just.
So So I guess what they asked me is how come dot text section, which is so if you look at a MCU has two memories. One is flash
Right.
and one is ROM. One is
Hmm.
RAM. How does
Right.
text
Wrong.
section ROM and RAM, as they call it in naming
Right.
convention?
Right. Right.
Uh, how does text section ends up in ROM? Can I
Right.
move it to RAM?
Okay. Fair. Okay. So majorly what I'm able to, distill out of all of what you spoke was there seems to be like a controller involved of
Hmm.
some kind, right? That was number one. The second was being able to program it, and in this case using C. Like I see C scattered around, and then with respect to the controller, there was like this idea of peripherals
Hmm.
and memory, right? And then somewhere the third thing was, let me call it tools, right? In which
Yes.
case you talked about like the linker script.
Yes.
Yeah. Okay. All right. Okay. This sounds good enough. Let me ask you this. Let's say you were back at your old job. You got a chance to interview somebody fresh or 2 3 years experience. Would you stress on these topics? Would a signal around these be good enough for you? Well, you
Yes.
personally, we're not talking about other,
Yeah.
interviewers.
So again, like I would talk around these topics.
Mm-hmm.
Like I am specifically a big fan of asking bit manipulation questions.
Okay. Fair. But then bit manipulation, when we say that's, part of the C language, right?
Yeah.
Which we'll come to.
Yeah, the reason I like to ask bit manipulation is because this is something people don't cram on lead code.
Yeah, okay.
So you'd clearly get to know the person whether he genuinely put his brain or knows some pattern and just following that pattern.
Right.
So
This separates the wheat from the chaff. Yeah,
yeah.
definitely.
So and what I'm like, and knowing and working in the embedded industry for this long, I understand that since the industry is so wide and you can people come from a, specifically if you are 3-5 years experienced, you can come from a very different background than I am from.
Mm-hmm.
So the only thing I look at is how close can you get to the solution, even if I give you a hint.
Okay. Okay. Fair. So that's
Because
your.
you
Hmm.
cannot know anything about embed. You cannot know everything about embed, right? It's always
True.
on
True.
job training. The what you do on job is very different than what you feel in the coding interviews or what you learn in the books.
In general, sure. Yes.
Yes.
Okay. That
So
that makes sense.
that is different apart. But yes, if you know a bit basics of like very minimal of computer architecture, you don't need to know very specifics of a very single processor like ARM, etc. But you can simply define me
Mm-hmm.
what is a CPU and what is something CPU or peripheral. I'm fine with
Hmm.
it. If you can tell, if you know a bit of C and a bit of tools around it, like compiler and linker, I guess as a fresher, you are good enough to get into a industry.
Right. Fair. I mean, someone would offer you a job, right?
Someone would offer you a job.
Most. Yeah. Yeah. It well, if not that, then at least it maximizes your chances. Let's put it
Yeah.
that way.
Yes.
Just being politically correct. So okay, that's that.
Yeah.
Again, reiterating, we talked about somewhere controller, and I think controller was representing computer architecture. Knowing something about computer architecture helps. Knowing C programming down to bit manipulation. I would also add like pointers here. I think that's super important, right? So knowing pointers, bit manipulation, I think that is good to know. And then tools, compilers, linkers, all of that. Cool. So, Rajat, would it be fair to say that all of this has helped you in your career? If not anything, getting into the industry and then being able to contribute. Would you say this was enough in terms of contributing, being like a useful teammate? You are muted. You are muted.
Yeah.
Yeah.
So I think it is good enough to start with, but let's say
Yes.
if a person, if I'm interviewing a 3 to 5 years old person, I am much more interested in his debugging skills than programming skills.
Sure. I think debug is something we can take. But we are talking about, okay, this is for experienced.
Experienced. And I will tell you the reason is the thing, and this again goes back to what differentiates embedded engineers from software engineers, right? So when you
Okay.
are debugging, when you are an embedded engineer and you are debugging a hardware, you don't assume that hardware is working fine.
Right.
You always first blame the hardware.
Well, true. Okay, I do
While
that.
software engineers always never blame the hardware. For them, the
But
hardware should work fine.
sure, I think I need to call out this one distinction, which is because I mentioned that I blame the hardware.
Yeah.
Uh, so it's like the kind of hardware I have gotten to work with was like always in design, right?
Yes.
So there were reasons to believe that the hardware can misbehave. Uh, but in general, I think once you have a chip out there, STM or Texas Instruments, something, some controller, some board, the chances I doubt the hardware are like rare. I tend to doubt the firmware a lot more. But cool. I think I understand this now. So debug is something that you focus on, or
Yeah.
prefer, give more weightage to for an experienced person versus
Yes.
the earlier, like these three majorly for starters, for freshers.
Yes.
Okay, cool. So let's move on to someone else now, and maybe they can guide through how their journey was so far in terms of what all helped them. Who wants to go next? I
Okay.
see Dave is unmuted, so
Yeah.
let's go to Dave. Yeah, go ahead. So
So
what all helped you get into the role or the place that you are in terms of embedded software engineering?
okay. So I think during college days, you know, I wasn't much of embedded, you know, enthusiast. I would say that. I think only subjects that I, like a typical computer science student would learn is the microprocessor,
Mm-hmm.
and then the computer architecture, right?
Okay.
So these are two subjects that are, from embedded domain that are being taught in college for a CS graduate. And I think if
Okay.
someone is from electronics, communication, all other branches, they would be learning more about embedded system, and rather than just a basic of things, right?
Okay.
So I think going through these two fundamental subjects
Mm-hmm.
would definitely clear your basics.
Okay.
And since I think what Rajat mentioned, right, it's a very vast domain. You cannot learn everything, but
Mm-hmm.
what you can do is learn basics of everything, right?
Yes. So
Right.
you're
So
saying microprocessor and computer architecture are those basics.
right, yeah.
Okay. Fair.
And I
Fair.
think like you can learn about a basic CPU model, like
Okay.
the basic memory model, the basic
Okay.
peripheral and interrupt exception, all those things, right?
Okay.
And then a bit of the tool that what Rajat mentioned, right? Like the compiler, the assembler, and all of those things, right?
Right.
And with that, right, you could have some sense, okay, what all things are going to come on your way, right?
Okay.
And of course, right, being a computer science student, you would obviously would have gone through C programming, basics
Mm-hmm.
of C, and then the pointers and all those things, right?
Okay.
And I think this is pretty much enough for a student to get into the embedded role as a fresher.
Well,
But
maybe not get into or have like a high probability, because there is always a
yes,
chance that you don't know
yeah,
something that is absolutely critical for
yeah,
a position.
yeah, yeah. I think it doesn't guarantee you, but it would
Hmm.
have your chances maximized, right?
Hmm.
Yeah. So I think
Definitely.
these are pretty much things that I knew when I was out of college.
Okay.
And actually, I did wanted to go into embedded domain.
Okay.
Initially,
Yeah.
that
Yeah.
that was not my plan.
Okay.
But I think after a year, I ended up in an embedded role,
Yeah.
and
Life happened.
I try to learn things on those
Okay.
basics, and then I built on top of that, right? So
Okay. So let's talk about that then, because let me also summarize. So in your student years, things that you knew or kind of had, on the back of your mind were microprocessors, computer architecture here and there, C programming language. Did you know the basics of CPU model, memory model, all
yes,
of that? Oh, you knew. Okay.
yes, the CPU
Fair.
pipeline, the memory, the hierarchy, and then all, like we also have the
Hmm.
caching model, right?
Hmm.
Where
Hmm.
you typically understand the hit and miss, how it,
I
how
see. I
something
see. I see.
happens, right, and how it
But
is being
then
cached.
that was part of the microprocessors course, or I think it must have been
Park.
computer architecture.
Computer architecture, yes.
Sorry, what was it,
And
Rajat?
No, I was just saying
Compark.
Compark.
Yeah.
yeah,
Go ahead. Go ahead, Dave.
and also I think a bit of memory interfacing and all those things of nature. And
Right. So, memory mapped IO.
hmm,
Okay. Fair.
and I
All
think
right.
like whatever I have mentioned, right, these are typically being taught in uh, you know
Right. And
EC, yes,
yeah,
like
usual CS and EC courses actually do touch upon, computer architecture, or
right,
if not anything, computer organization, which is also,
right,
same. It kind of, well, not same, focuses on different things, but covers what is required for,
right.
kind of contributing in embedded systems. Okay, cool. So now, did you also happen to know about the compiler and the tool chain? Like, did you know GCC and variants of it?
Yes,
Or
I wasn't so sure about the tool chain, but I
Okay.
wasn't, I was basic. I had the basic understanding of
Hmm.
how compiler and assembler works,
I see
and
how you go from C to machine
of
code.
assembly language as well.
Okay. And
Yeah.
you had some idea of assembly. Okay, I need to also ask one last question about your student life, which is um, in the microprocessors, which microprocessors did you focus on?
I think it was 8085.
Okay, this was
Yeah.
8085.
Yeah.
All right. Well, yeah, kind of prehistoric times
Right.
here.
Yeah.
But fair. I think any microprocessor is good enough.
Hmm.
All right, now let's talk about after you got a job, how did things change? What all did you add on to your pre-existing arsenal?
I think typically what happens is that out of these things,
Also,
you would
could you speak closer to the mic? I think we can.
yeah, sure.
Yeah.
So
Okay.
out of college, right, you would land into one of these domains, right? Like if you are working on a CPU, if you are working on a memory model, if you are working with some peripheral, right? So from there you would start learning that specific domain, right?
Mm-hmm.
And you could go through a lot of online available resources. So I
Mm-hmm.
personally went through system level cache,
Okay.
and that was my initial projects, writing software for system level cache. And there,
Okay.
I think there are plenty of resources online, and I dealt deeper into all those things. And given that I had some basic understanding of how SLC works, I could easily build my theory on top of that, and could become an expert, right?
Right.
So
So I'm kind of just wanting to focus on the keyword caches. So essentially,
right.
went in the direction of and learned a lot more about caches. Right. That would be fair.
Right.
Okay. I think my
Yeah.
background
Yeah.
is blinking. Let me get that sorted. Okay. Perfect. All right. So you kind of spent your early years on, studying more about caches, which, again go back to, I suppose, the memory model.
Yes, memory model and all.
Okay.
Yeah.
Okay. And then how did you, okay, in terms of the language and the skill set, what all did you improve on, or was there anything new that you had to pick up?
I think like the language that we know, the C programming that we know at the level of a college,
Mm-hmm.
we would know very basic things. We would use it to just do some algorithmic or coding problems,
Mm-hmm.
right?
Mm-hmm.
But when you delve into the industry, it has a different C, taste, right? It's completely. I wouldn't say completely, but it would like being a college graduate.
Mm-hmm.
If you look at the industry uh, level software that are written in C,
Mm-hmm.
you would not understand
Oh yeah,
anything
of
there,
course.
right?
So let me
Yeah.
help you, and you can correct me if I got this wrong. I suppose
Yeah.
the set of keywords in C that get used very heavily are different. Different in the sense,
Yes.
like back in college, you would be using, you would be writing like algorithms which don't use bit manipulation
Right.
usually. They don't use pointer
Right.
dereferencing. You don't use as
Right.
many macros. So all those are like heavy. But did I get that right?
Right. Yes.
Okay, so I'll
Yes.
just
And I think typically things like you would use, instead of int, you would use uint32.
right,
Instead
right,
of long int, you would use uint64p,
right,
and things of these nature, right?
right.
So these are typically things that you may not know
Mm,
during your college, but when you run into industry level software,
right.
you would have to learn those
Mm-hmm,
things. And I would say it's easy. You can easily map things from what you have learned during your college
mm-hmm.
to industry, right?
Yeah,
So
but I think it's just, let me maybe then call it this way, that you had to change your mindset a little bit when thinking about
right.
the C programming language, right? So this was more of
Right.
a mindset. Okay. this was more of a mindset change.
Yes.
Right. Okay. Anything that surprised you here? Anything that was like, wow, new?
I wouldn't say anything new,
Mm.
but it was all like you had that basic understanding,
Mm.
and when you delved deeper into things, you would realize that okay, whatever you learned
Mm-hmm.
in the past,
Mm-hmm.
that's a pretty small, a fraction of what you would learn today, right?
Okay, on job. Okay.
And when you delve deeper into things, you would realize that there was something that you may have learned, but you didn't know what
It was
uh,
used for.
like what it was used for and why it was the way it was,
Fair.
right? And when you really understand
Mm.
the delve deeper
Mm-hmm.
and then understand things, you would know okay, you can easily connect the dots, right? Back to what you learned, right? So
Fair. Okay, I think that makes sense. So did we miss, and I'm assuming that these were the only things that you have kind of, dabbled with so far, or there are other things?
I think, after system level cache, I worked on various things
Mm-hmm.
like the security, different firmwares, different you know firmware modules, kernel modules, all of those things of that nature.
Okay.
But yeah, like that. But that was the extension of what
Okay.
I was already
So
learning.
I'm
So
kind of going to, okay, can't spell things. Is this correct? I don't know. So C language is something. Then
yeah.
Oh God, where is my eraser? Yes, computer. Okay, computer architecture. Then memory model, and I would say then just that, maybe kernel here and there. You talked about kernel and firmwares. But I
Mhm.
suppose kernel and firmwares go back to mostly because they are written in C than that. But then I'm thinking these three were what helped you most. Fair?
Yeah.
All right, cool.
Yeah.
Okay, then with this, maybe let's move on to Wasim. Wasim, do you want to talk on how your college days were and what is helping you in a
Sure.
minute? Yeah, let's.
So, uh, when I was a fresh grad, so at that time I was knowing like little bit of C.
Mm-hmm.
So that too, I was knowing C, so I can implement some algorithms
Okay,
like
fair.
bubble chart,
Right,
merge sort,
right.
and binary trees, or reversing a linked list
Mm-hmm.
kind of thing. Okay, so and at that time also we were having a subject called computer organization, and in the computer organization we have covered the 8051 and 8085. So I had a little bit of hands-on on 8051 and 8085,
Mm-hmm.
and
Rajat,
we
could you
also
could you mute because the keyboard? Oh, okay. Right.
yeah, and I was also
Right.
having some experience
Wasim, could
of
you, sorry to interrupt you. Could you pull your mic a little closer? Yeah.
okay,
Yes.
is
This
it
is
fine?
this is great. Yeah.
Yeah, and my project was on pick controller, so I was knowing like how to use some software to program the pick controller.
Okay. So this was
Okay,
like
so
programming a big controller. Yeah.
yes. So this is the place where I started,
Mm-hmm.
and but these things was not able to get into the job.
Okay.
So I have to take a training for 6 months
Okay.
on embedded systems.
Okay.
Okay, so I'll tell you what are the things I read there and what are the things helped me to get the job.
Right.
So it was like
And also,
it
just a
was
moment,
not the low
just a
level
moment,
embedded.
just a moment. So before
Yeah,
we proceed, as a student, what was your background? Computer science, something else?
electronics and communication.
Okay, so you were an ECE. Rajat, what was your background? ECE?
Electronics
Yeah, okay.
and communication.
Okay, so we have like one CS, two ECE. Go ahead, Wasim. Yeah, so you took 6 months
Yeah,
training.
so I went through the 6 month of training. So here it was very generic training,
Mm-hmm.
and it was catering to all the embedded system jobs which was available there in the market.
Okay.
So so the first phase of training was like embedded application development.
Okay.
So knowing C++ and C and some GUI library,
Mm-hmm.
they taught like they have given some basic idea,
Mm-hmm.
Qt and TK.
Mm-hmm.
Okay, so here I learned C and C++.
Okay.
Okay, and in the second phase,
What was
they
it?
taught
Qt and
me
TK, was it?
these are the
Right.
libraries which is used to develop the graphical interface of embedded software. The
Understood.
software be a control system of
Mm.
any embedded device. Okay, and after that, we moved to the middleware development. There I learned about system programming and different IPCs,
Okay.
IPv6, IPv4, and POSIX
Okay.
standards of IPC communication.
Mm-hmm.
And then the last thing they taught us like kernel programming, and there I learned writing some kernel modules in the phase 3.
Okay, this was not part of phase two.
Yeah, this was the phase 2 was system programming.
Mm-hmm. And middle level?
Yeah, so in the middle level layer, what you develop like a layer which talks with application
Right.
and your kernel.
Right.
Okay, so the system programming comes in, and you must be know about how to like the fork, v fork,
OS constructs.
these
Okay.
OS constructs.
Right.
So system programming. Uh, they the book material which I got was Michael Curry's System Programming.
Okay.
Okay, so
And
it is a
spell it.
famous book.
Michael what?
Yeah, Curry's. I cannot spell
Okay,
the name, but
we'll
it's
link it in the description. I think that would be best.
And then the kernel programming started, and here we did very few like we learned about kernel porting, how to compile and port the kernel in Ubuntu.
Mm-hmm. And when you're talking
And
about the kernel here, that's the Linux kernel?
Linux kernel.
Okay, fair. This was okay.
And here we learn how to write SPI and UART kernel as a kernel modules.
Okay, SPI and UART as kernel modules.
Yeah.
Okay.
So it was not full-fledged driver, but
Like
we
the
were
basics.
able to transact. Yeah, like a basics, doing transactions.
Mm-hmm.
So yeah, so this was the thing, and I got the job. And in the job, they were more interested about the kernel programming
Okay.
and system programming.
Okay.
So the job which I landed was mostly on the middleware and kernel programming.
Okay.
Okay.
And all of this was in C, I'm assuming.
Yeah, it was on C.
Okay. So all of this was in C again. Right.
Yeah.
Okay.
So here we were providing the supports, means the framework was there and we have to enhance the support.
Mm-hmm.
So driver team used to add the driver.
Mm-hmm.
Our framework team used to write the APIs so the application can connect with that driver.
I see.
So we were just enhancing the framework to the new drivers
Okay.
or components attached.
So I'm an EE graduate, right? So as a student, I also had, microcontroller somewhere, right? And this was like very basic. We 8085, right? And this was just assembly, programming for us. We didn't have the C based. That said, I also had C language in my curriculum and digital electronics, right? So I only kind of would say that these are the major things that have helped me, and maybe somewhere uh, there was also analog electronics that helps me reason better about things. Not that I needed it ever, but it just helps me reason better. So I just knew these when I graduated. That have helped me in my journey towards embedded. There were other things also. Then I did masters in embedded systems, which changes the game completely for me. Um, you know, and I did masters in embedded system only because I knew CPUs are involved, and using CPUs I can affect the real world, right? Then here we had like a course on ARM and 8081. This is where we used assembly and C to program the controllers. Also, tool chain. First time I got to know about the GCC and all of that here, in the sense that back here it was just like a compiler, call GCC, it compiles. Here it was more like what it does, how it goes from C to the machine code, right? Okay, so that definitely helped me. And then there were also like Linux kernel. Oh god, where is my eraser? Yeah, so kernel development related, so driver development. And we also had HDL, hardware definition or hardware description language based, Verilog, and VHDL based circuit design. Right. So now I'll tell you what got me my job. So the job interview was mostly around the C language, right? And in this kind of, again, knowing structs, pointers, function pointers, that helped me. Bit manipulation. So all of this helped me. And then on my job I got an internship for 1 year. This was with Intel, right? And I was able to just use the C language and the compilers to implement a memory manager. So that was my first assignment. Okay, memory management somewhere, right? So that was, I would say, my first assignment. And then after that, I went on to writing drivers, in which again I used C very heavily. And within C, I would say structs, pointers, and function pointers. And then in the current job, I'm using like a lot of computer architecture also. So that has been pretty much what helped me majorly. So now, when I was saying that I see a pattern here, so maybe, we can just summarize for our audience and, end the call for today, which is the summary is, in my opinion, and you can jump in also, knowing C is kind of a must, right? You cannot do away with this. You've got to know this. And even in C, then you need to know pointers, structs, bit manipulation. And then within pointers, you should know function pointers, right? How to, also, I would say, let me put it this way, data types, right? And then you should know how to mix data types and function pointers into a struct. I think that is valuable and important. Then we also saw computer architecture or organization. I think that gives a sense of how the CPU works. So people should know something about that. Memory models and peripherals. And then the third thing I noticed that was common was the build tools, right? In which case you've got like the GCC and friends. Friends, then you also had like make. And I would also go ahead and maybe add, because none of you, kind of specifically hinted at that, but it was involved, which is the Linux shell scripting. This makes life easy. So yeah, I would say, if someone is starting off or wanting to head towards embedded, these are pretty good things to know. Would you guys agree? And then
Yes.
I'm seeing that somewhere in everyone's journey that was like somewhere there was these things that were common. Okay, did I cover the ground in enough details? And did I summarize it accurately?
Yes.
Okay,
Yes,
perfect.
yeah.
So Rajat was hinting earlier that we might go over time, but I think this is good. If someone wants to again consider a career in embedded, these are pretty good things to start off and consider spending time on. Yeah. So if
Yeah.
no one, yeah, go ahead.
I think most of these things are being taught in
Yeah,
college.
definitely.
So don't skip the classes and then understand them thoroughly.
Yeah.
And that's the basic things
Yeah.
that is required.
Yeah.
So yeah.
And maybe what we can do is, based on the feedback that we get from our audience on this video, this particular session, we can decide to dive into the details of, whatever topics later on. That sounds good. Okay.
Yep.
Cool. I think
Yep.
then,
Yep.
we should call it a podcast for today, and we should think about like the next topic that we can discuss on. Okay, cool. So let me go ahead and stop the recording then.